Now the second procedures or the second techniques for hazard is hazard surveys. Okay, first you are already dealing with checklist. Okay, now you are dealing with surveys. Okay, the second technique is hazard surveys. Okay, what is hazard surveys? Actually, it's a simple inventory of hazardous materials. Okay, hazard surveys for a simple one is an inventory of hazardous material, while the complex or very detailed hazard surveys can be found in, for example, Dow Fire and Explosion Index (FEI) and also Dow Chemical Exposure Index (CEI). Okay, FEI or CEI. So the Dow Index provide penalties for hazards and credits for safety for equipment or procedures. So let's say you have one equipment and the equipment itself have so many hazards. So you have so many penalties and a little bit of credits. So when your penalties is more than your credits, you can make a conclusion that this equipment is not safe or is not suitable to be operated. Okay, so what is FEI? Okay, it's a ranking system. It's a ranking system that have an index to the risk of individual processes unit. Okay, because it is a fire and explosion index, this system have an index to identify which equipment have the potential for fires and explosion. Okay, while for chemical exposure index is an index. Okay, simple method which has an index that relatively have a acute hazard potential for people in neighboring plants or communities or surrounding this equipment. Okay, so one surveys is involving fire and explosion. Another surveys is involving hazardous chemical or chemical exposure index. Okay, so the complex and detailed procedures for hazard surveys can be carried out by individual or also by a group. Okay, the rates relative hazard of storing, handling, and processing this flammable and explosive material can also be determined by this individual. Okay, so how you make your surveys? Okay, how you make your surveys? So the systematic approach for your hazard surveys can be divided into a few steps. Okay, the first one is to break the process down into units. Okay, that's a very basic one. Okay, from your large plant you break it into a few area or section. Then from that section you break down into a process, and then you break into units. Okay, so you have your only reactor, storage, pump, heat exchanger, column, okay, as your units. Okay, then the individual should have an experience, so use the experience to select the units that have the highest likelihood of a significant hazard. Because if you want to make a survey for the overall plant, it's too many to cover. Okay, so you can select the one that have a likelihood of significant hazard. Okay, after you select your units, then you can define your material factor. So for example, what chemical are being used? The higher the value of the flammable or explosive item that you use, the higher the material factor. And then this value will be adjusted with various penalties based on the condition of the storage. Is it below or above the normal boiling point, exothermic ration in the process, and so on. Okay, that penalty is based on the operating condition and also the situation for that chemicals. Then you can take the credit for safety procedures and safety system. before finally you can arrive at number that the rates of hazard. So you know what is the rate for that hazard. Is it below or above the standard rates? Okay, we look the example here. Okay, this is a standard FEI form. Okay, so this is the penalties for the hazard. Okay, you have your material factor for all the surveys that you have done. Okay, so each item have their specific factor. Okay, that's why this survey should be done by very expert. Okay, they have the, experience in handling all of these hazard. Okay, so that they know how the factor or how the penalties should be evaluated. Okay, because from the form, the penalties may range from, for example, here is 0.2 until 0.4. So what is the suitable penalties that can be put inside here for the endothermic process? Maybe because for the endothermic process, maybe the factor of the range of the penalty factor may be based on the type of the endothermic process. How much is their energy, okay, being absorbed, and so on. Okay, so these penalty factors can be evaluated by this committee or this individual. Okay, another FEI form. Also, you can use, you can see the loss control credit factors for the buildings, material, and also the process control. Later on, we will see one of the example of hazard survey, how it can be conducted. Okay, you have your selected data for Dow FEI index. Okay, this is the material factor. If your process involve acetone, so you have your material factor of 16. You have your heat of combustion, flash point, and also boiling point information. So this material factor is important during your service. Okay, there also the degree of hazard from Dow FEI. So after you make your calculation, okay, from your form, you make your calculation. This is the formula for your FEI index. Okay, you have your F1. Okay, this is your general hazard factor, F1. Then you have your special process hazard factor, F2. After you giving all the credits and okay, you give your credits and penalties. Okay, so the penalties and credit that involved here will be calculated, F1 and F2. So you have your process unit hazard factor, F1 times F2. This is your F3, the value of your service. Okay, F3. And finally, the FEI index will be obtained after you get your F3 times your material factor. So this, your FEI index, can be compared with this degree of hazard. So if your value or your FEI index is around 1 until 60, so your degree of hazard is light because there are not so many penalties in your service. So you can see 159 and above, the degree of hazard is severe. Okay, so the index is following from light until severe. Okay, the severity of hazard here. Okay, this is the example for hazard survey. Okay, you can see the plan considering installation of new rail car. Okay, let's say we make an analysis here with highlighter. Okay, So your plan is considering the installation of new railcar tank unloading facility. The facility will unload nominal 25,000 gallon of tank car. Okay, this is 25,000 tank car. It's a very big tank car. Okay, containing either pure butadiene and or cyclohexane. Okay, this is your materials. Okay, this is your chemicals. The unloading system will be equipped with an emergency shutdown system with remotely operated block valve. So you have two prevention system here. Okay, one is the emergency shutdown system. Another one is your block valve. The unloading operation will be done by computer control. Okay, so you also have your process control as your risk control precaution. So the railcar are inerted with nitrogen to a pressure of 40 psi, and the railcar relief system have a preset pressure of 75 psi. The unloading operating instructions are written and have been reviewed by the corporate technical staff. A reactive chemicals review has already been complete on the proposed facility. The combustible gas detectors will be located at the unloading station. A deluge system will be installed at the unloading site with an excellent water supply. A diking system will surround 3 sides of the facility. Okay, they have a diking system. Okay, will surround 3 sides of the facility with any spill directed to a covered impounding area. Okay, so determine what is the door FEI. Okay, for this operation and determine the minimum spacing from adjacent unit. Okay, so this is our question. Okay, we will look what is the solution for this situation. Okay, so the solution, you have your butadiene and also cyclohexane. What is their material factor? 24 and 16. So the question is, where this material factor will be used? Okay, this material factor will be used later on. Okay, after you get your factor 1 and factor 2 value. Okay, so you got your factor 1, factor 2, you times factor 1 and with factor 2, then you times your factor 3. Okay, factor 3 is a result of factor 1 times factor 2. So factor 3 will times with material factor. Okay, so this is the toughest part. Okay, how about the material handling and transfer? What are the penalty factor used? From here they give 0.5 based on their service. Okay, that's the important thing of service, because service means you got you be in the plant, you look what is the process, you look how they handling or transferring this chemical, so you can give the penalty factors based on situation. Okay, so they give 0.5 from 0.25 until 1.05. It means it is in the middle. So the process upset or the push failure, what is their penalties? So the factor only 0.3. So there are no range for these penalties. If you have your purging system, if the purging system have been installed in the equipment, you should give it 0.3. If the accident occurred, the penalties is 0.3. So you give them 0.3. Okay, so if the tank farm storage have a flammable liquids, we give the penalty 0.5. okay, and so on.